Alright, hello folks. I've got another video here for you. Got some examples that we're following up with on the chain rule. So, talked about this before, had an introduction, talked about the formula, looked at a couple examples, and now we'll go a little bit more in depth, work some of these examples out. So let's see what we got. So I want to compute the derivative for this function, f of x, is 2x plus 7 quantity cubed times 5x minus 1 that quantity to the fourth. So I've got the solution worked out down here, so let's see if we can get there. First thing we want to note is that we're going to use the product rule first. Right, because I see this as this function times this function. So I'm going to use the product rule, and then in the course of doing that, I'm going to use the chain rule for the factor derivatives, for derivatives of these factors that we need to know along the way. So product rule first, the derivative is derivative of this guy, and I'm going to write it like this first time going through, times the second function plus the first function times the derivative of the second function. So product rule first, that's what I'm doing there, and then in the course of figuring these out, that's where we're going to use the chain rule. So chain rule tells me got a power rule for the outside function there, and nice linear function for the inside. So I've got 3 times 2x plus 7 squared. Then the derivative of the inside is just 2. And then I've still got this part, so 5x minus 1 to the fourth plus 2x plus 7 cubed times, now the chain rule for this part, 4 comes down, 5x minus 1 cubed times the derivative of the inside, linear function there, the derivative is just 5. Let me try to see if I can emphasize this a different way. So, using that blue ink over and over maybe is maybe I just made it worse, I don't know, but try to keep track of what we're looking at. Perfectly fine answer here. We've got f prime of x, not very clean or easy to deal with. So to get from here to the solution that I have posted is just a matter of being careful and clever and whatnot with your factoring. So I guess what I could do is I've got two terms in the sum here. So I've got a common 2, because I've got a 2 there. I've got 2x plus 7 squared in both. I've got 3 copies of 5x minus 1. That would be the common factor from both of these. And then what's left over is I've got a 3 times 5x minus 1. So one of those left over. Plus, one of the 2's is factored out, so 2 times 5 is 10. I've got another copy of 2x plus 7, and my 5x minus 1 cubed, all those are factored out. So, got that. Good, good, good. And if you expand, you'd have, what, 15x plus 20x, there's your 35x. 10 times 7 is 70, minus 3, there's your 67. So we've got our solution. I'm just showing how we got there. Again, this is a little bit trickier because we're doing multiple steps. You have to recognize that we do the product rule and then the chain rule. Alright, so another one here, and let me try to do this a little bit better. So we're trying to find the derivative, and we've got couple applications of rules here. First of all, I'm going to see that I use the quotient rule, because I see this as a function divided by a function, first and foremost. In the process of doing that, I need to know the derivative of the numerator, the derivative of the denominator. The derivative of the denominator will require me to use the chain rule. So let's see how we do that. So the quotient rule tells me to take the derivative of the numerator, which is 5 times the denominator, 6x plus 1 quantity cubed, minus the numerator, 5x minus 4, times the derivative of the denominator. And there was a little bit more detail in the last example, but maybe we're starting to get the hang of this, so I'll work a little bit faster. Now the denominator is squared, so I went ahead and took care of that. For this part, this is going to be the derivative of that denominator function. So maybe just to emphasize that, we'll use green. But the 3 comes down, times 6x plus 1 quantity squared. So power rule on the outside times the derivative of the inside, which is 6. So perfectly fine answer, but if I wanted to clean this up just a little bit, I could say I've got 6x plus 1 squared, all that times 5 times 6x plus 1, minus 18, the 3 times 6, times 5x minus 4. So I'm just doing some factoring. I've got a common term of 6x plus 1 squared in both terms in that sum. In the denominator, I've got 6x plus 1 to the 6th. So I can cancel a little bit there. I got some common factors. And so I end up with 30x plus 5 minus 18 times 5 is, I guess, 90x, and then 18 times 4, I guess, from golf, I guess I would say it's 72, 18 times 4, right? 72. And then combining those terms, 5 plus 72 is 77. 30x minus 90x is 60x. So got our solution. So again, quotient rule, and then along the way the chain rule. The chain rule is what we're doing right here when we figure out the derivative of that denominator. Alright, what else can we do? Repeat the second derivative. Oh boy. Alright, well let's see what we got. We're going to start off using, there's just one rule to use for finding this derivative. This first derivative, and that would be the chain rule. So chain rule for f prime, and then out of 3 halves, x squared plus 1, 3 halves minus 1 is 1 half, times the derivative of the inside, which is 2x. And if I want to clean that up just a little bit, I've got 3x, because the 2's cancel there, times x squared plus 1 to the 1 half. I might like to write that as square root of x squared plus 1, but I know that I'm going to differentiate again, and I like to have this exponent notation, so I'm going to keep it like that just for now. So for the second derivative, I'm going to run out of space, but let me say PR for product rule and CR for chain rule for the second derivative. So the second derivative is the derivative of the derivative. So I'm taking the derivative of this guy right here. So the first function is 3x. Derivative of that is 3 times x squared plus 1 to the 1 half, plus the first function times the derivative of the second. And there, I'm going to be using the chain rule. So I'm going to do like I did on the last example and just try to emphasize that with a different color. So it's 1 half comes down, x squared plus 1, and 1 half minus 1 is the negative 1 half exponent, times the derivative of the inside, which is 2x. And then making it look like the solution that's provided here is just a matter of kind of cleaning this up with a little bit of algebra, I guess. We could say this is the same as, well, let's look at this part first. So I've got 3x, oh no. Alright folks, so we had a pause there that you won't know too much about, but the pen stopped working that I'm using, so about more than halfway through this video, so I'm going to finish it up, but I'm going to use the mouse, so it's not going to be great, but figure out my technology stuff later. So for this to, let's see, it's going to be terrible, but it is what it is. So what we've got is we got that for a denominator, a common denominator from these terms. So from this one, we're just going to have the 3x. This is so terrible, I'm sorry. I can't get my technology to work. So we've got the 3x times x, so 3x squared from there. Here, to get that common denominator of square root of x squared plus 1, I would multiply by x squared plus 1 over x squared plus 1, and that would give me that common denominator, that denominator that I want. So what that means is I would have 3 times x squared plus 1. Again, really sorry for the handwriting here. The pen just crapped out. Anyway. So, hopefully we're okay from there to there, if that makes sense. Again, that common denominator of square root of x squared plus 1 is what we're looking for. So, what can I say? Distribute the 3 through, and you've got 3 times x squared plus 3 plus 3 times x squared, so 6x squared plus 3, and then in the final answer factor the 3 back out. So we do get from here to here with a little quick factoring for that one. So I have one more problem for you for the examples, but with the pen doing what it did, I think I'm going to end it here. Got a nice example of second derivative. Starts out pretty easy with the chain rule, like we said, and then for second derivative starts to get a little bit more complicated. We've got to use both the chain rule along the way, but initially we'd use the product rule.